Hello guys, my name is Desmond and I welcome you to my lesson for today, where we'll be looking at your physical sciences. As you can see over there, it is electric circuits. So ladies and gentlemen, please do allow me to say it is very much important that I say it is very, very much important because what I'm about to say is massively, 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 massive. Hey, massively important, ladies and gentlemen, that I say a day without learning something new, it's a day wasted. Crazy. Please, 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 please. Nontokozo, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Very, very much important, ladies and gentlemen, over there. So, once again, please make sure that at all times, you pay full attention to all the details. So, you guys did confirm that you are able to see over there. Okay, so what I'm going to be doing in today's lesson is just to take you through this given diagram. And most importantly, guys, take you through the questions and how you approach this type of questions. Very, very much important, ladies and gentlemen, that you stay until the end of this lesson. And a very warm welcome to our new learners who are attending my lessons for the very first time today. Just make sure that you stay until the end of the lesson. And most importantly, in case if you've got a question, just make sure to mention your name and I'll give you an opportunity to ask a question. Otherwise, in case if I'm asking a question and you want to answer, just mention your name and I will recognize you, honorable member. Last thing, do not leave me to move to the next question before you understanding the answer to the previous question. I would like to just take away that and explain something to you guys very quickly. As far as circuits are concerned, if you guys remember, I did say we have two types of circuits. Not necessarily two types of circuits, but let me say two types of connections. The first one being a series connection. The second one being a parallel connection. Okay. Something that you guys need to be aware of is that if you have a wire and you've got multiple resistors connected along that wire, this is the type of a connection that we call a series connection. And the total resistance that can be calculated is actually R1 plus R2 plus R3 plus any other resistors which might be connected there. For example, if we add some more, you just add whatever. And most importantly, we only have one formula to calculate the total resistance. Very, very much important, ladies and gentlemen, over there. So this is series connection. Let's quickly talk about parallel connection. So a parallel connection, maybe let me just do something similar to that so that it makes perfect sense. So we say we have that. We can also have that. We can also have that. We can also have that and also have that. Okay, so here we've got combination of connections. This one, let's say it's R1. This is in series. R2, it's in series. Then can you see what happens there? This thing, it now makes a branch whereby this is now, let's say, R3, which is in parallel. It's in parallel to what? To R4, which is on this side. This one being R5, it's in series. So you need to be aware that the formula which says 1 over R parallel is equals to 1 over R1 plus 1 over R2. Bantu bakithi, this formula is not for calculating the R total. It's not for calculating the total resistance, but it is for calculating the parallel resistance. What do we do when we calculate parallel connection? As I've said on my previous lessons, this is what I said. When you use this formula on that branch or on that connection, you are simply trying to combine these two parallel resistors, or those two resistors connected in parallel. You will still have this one being in series being R1. You will still have this one connected in series being R2. But this one is the combined. Let me use that and say that one, it is the combined resistance. So we call it RA parallel because this is the resistance that was calculated from a parallel connection. This formula, it only helps you to calculate the combined resistance. You will still have that one being R5, for example. So if, for example, they say, matume, zamurega mutahazi wena of 50 volts. Okay, that's you went to buy electricity of 50 volts. Okay, so that means this 50 volts, part of it is going to go to the kettle V1. So the voltmeter tells us how much of electricity is taken by the kettle. And then now we have a stove over there. Let's say V2. So voltmeter 2 is going to tell us how much of the stove used from that total. When it comes to parallel, Bantu Bakiti, the V, it is actually for all the resistors connected in parallel. So here, for example, you can regard maybe this as something like tune plug or whatever that you can think of, guys, just so that it makes sense or you easily remember that, for example, V3, whatever the amount from there, it gets to be for this and also for that. It is the same as that. Maybe let's say the other one goes to this. Maybe let's say this is going to be what? This is V3, this is V4. Let's say it's TV. So, madrume, you want to buy 50 volts of electricity or 50 units or whatever. I'm just trying to create a scenario. Let's say 5 volts goes to what did I say that is the kettle? And then let's say 20 volts goes to the stove. Here, let's say you have charged your power bank and your cell phone. So that means here, let's say maybe 5 volts goes to charging these two things connected in parallel. So the remaining will go to this. It could be washing machine or whatever. So what will be the remaining, guys? Let's see. We have 20, we have 5, we have 5. That means, what is it? Is it 20 which is remaining? I think it's 20. So that means 20 volts will go to that washing machine. So it has to be such that the electricity bought by Matrome, which is 50 volts. When you say this plus that V plus that V plus that V, it has to take you back to this electricity that Matrome has bought. So when it comes to the parallel connection, that means here the V for this thing, guys, it is 5 volts. Also, the V for this resistor, it is still 5 volts. That is why we said this V is actually for this resistor and also for that resistor. So this 5 volts, or the electricity that goes to the branch or the parallel connection, it does not split. It remains as 5, meaning this is going to be 5, this is going to be 5 volts. What happens is that the current flowing through there, it is the same, but when it gets there, it splits. Some of it will go to this side, some of it will go to that side, and then here it joins, then it is the same current. So remember, if you have, for example, let's say a 25 ohms this side, and you have 3 ohms this side, can you see there's more resistance on that side and less resistance on this side, which means the current flowing, more current will flow through this side because there is less resistance, less soldiers. On this side, you've got too many soldiers, which means less current will be flowing through that side. And also, examiner might not say calculate the current, calculate the voltage, calculate the resistance. They will just say, what is the reading on V1? What is the reading on A1? Maybe what is the resistance there? So you need to know that V actually is the voltmeter which calculates the voltage. A means the ammeter, which calculates the current. I'm not sure. Are we together there up to what I've explained before we start answering the questions, guys?
Yes, sir.
Mm-hmm. Last one to confirm.
Yes. Yes, sir.
Aripira mazona korula, ariparitira mazona koruma,
Yes, sir.
zona koruma, zona koruma. Oh. Hey, my chance. Let's now make use of this opportunity to try and work out this. Maybe let me quickly try to redraw that so that I will use that other one for questions. Zona goruma, zona goruma, zona goruma, zona goruma, zona goruma. Oh, anarume, zinina, zona ruma. Zona rumi. Okay, so let's see. I want to take you through, guys, what is going on over there. Okay, I hope all of you guys are able to see that we have one cell. We don't have a battery there. We have one cell. It's a battery when you have 2 or more cells. So the long line represent the positive side of the cell, and then the negative, that small one. So when the current flows, it flows from positive to negative. And also, madromele kajane baregile mutazi wa 15 volts. Okay, so now this is how the current is going to flow. It starts from the positive, then from there it goes to the other side, and this is what it does. Oh, oh, oh. Can you see? It gets to that point. What happens? It splits. Bantu bagiti. Some of the current will pass through this side, and the other one will pass through that side. So more current will pass through this side because we have less. Oh, hey, more current will pass through this side. And then when it gets to that point, it joins. Just think of water. You have water flowing through the pipe. Boom. Then from there, there's a T-junction. Some water will go through this side, the other one through that side. Less water there, more water. Hey, wait. I can sense there's someone who wanted to say something, but I did notice that. Here we have less resistance, meaning more current will flow through that side. Less current will flow through this side. Yes. Then there it joins. So can you guys notice how you make a mistake and rectify it? When you think about it as water flowing through a pipe, there's water that is flowing, and then more water will flow through this side because there's less resistance. Less water or current will flow through this side because there's more resistance. But when it gets to that point, as it continues, then now it is the current combined, and then there it joins. Then this is the continuation until you open a switch. But once you close the switch, then the same thing happens. Okay, so now what else can we talk about? So remember, guys, based on what I've said regarding the V, you went to buy 15 volts or 15 units of electricity. That means part of that 15 is going to go to the 3 ohm resistor. And then part of that 15 is going to go to this. So that means when you add the electricity that went to this electrical appliance and to these electrical appliances connected in parallel, when you add them together, it has to take you back to that amount of electricity bought by Madrome. I'm not sure, guys. Before I even ask you a question, let me say this V, it measures the amount of electricity that you have in your house, of which it is going to be 15, because that's what Madrome went to buy. So this V1, Bantu Bakit, this V1, it measures the electricity that went to the parallel branch or the parallel connection. You can still connect another voltmeter there to know how much went to that washing machine over there. I'm not sure. Is there someone who's got a question before we start answering the questions? Or all that I've explained, does it make sense to everyone? Hey, did you guys run away? Am I alone here?
No, sir, you are not alone.
But are you understanding the Honorable Kwezi?
Yes, sir, I do understand.
Okay, so let's now try to answer the questions. Okay, here comes a question which says calculate the effective resistance. Bantu bagit. The word effective simply means total. Very, very much important, ladies and gentlemen, over there. So it's more like they are saying calculate the total resistance. I said we only have one formula for the total resistance. Is there someone who wants to tell what is the formula for calculating the total resistance of a circuit? What does the formula say? Bathulile bantwana bakaThixo wase-George Kokhe. Hey, bantwana bakaNkulunkulu, what is the formula for calculating the R total of a circuit? No idea. Okay, this is the formula, guys. R tot it's equals to R1 plus R2 plus R3 plus any other resistors which may be connected in that circuit. Here we have the R connected in series being this one, plus we also have the R parallel in the R connected in parallel, which is that one. So that means on our formula we have a 3 ohms plus the R connected in parallel. So that means we'll need to use the formula for R parallel to calculate the combined resistance of those two resistors. The formula says 1 over R parallel is equals to 1 over R1 plus 1 over R2. Okay, maybe let me continue. That means this is 1 over, what is R1? You can maybe say 2 or 4, it doesn't matter. Then over that other one. Therefore, what will R parallel be? And remember, guys, your R parallel has to be smaller than the smallest resistor. So if you have 2 and 4, when you use the R parallel, the answer, it has to be less than 2 because 2 is the less resistor between those two. So your answer must be less than the smallest. It must be less than 2. So what is R parallel? Do you guys know how to calculate R parallel?
So it's 3 over 4, which is 0.75.
Someone is saying is 0.75 ohms. Do you guys agree with that?
Yes, sir.
Is
Yes,
it
sir.
everyone who agrees? Okay. Then in that case, what you guys have done, guys, it's more like there you have that resistor of 3 ohms. And then what you did, it's more like you combined that one. And then you made it to be 0.75 ohms. That's what a parallel formula does. I used to say it serialize. So it's more like what we have done is to serialize this parallel connection. So can you see, you have that being in series, it has always been in series, then you just serialized this one. So it's more like you made it just one, which is the same as that. So now you can substitute it there into the formula, which means R tot is actually equals to 3 plus 0.75 ohms, which means this is actually equals to 3.75 ohms. Let me just confirm something. I'm just wondering what's going on there, and I'm suspecting you guys did not get it incorrectly. Plus 1 over 4. Bantu bagiti. Why are you guys doing this to me? Shreyas. I knew it. I knew it. I'm just going to have to remove all of this and explain wat gaan aan. Guys, when you have 1 over r parallel is equals to 1 over 2 plus 1 over 4. The answer that you get is 1 over r parallel. When you punch all of this on your calculator, you get 3 over 4. 3 over 4 is not r parallel. It is 1 over r parallel. You need to cross multiply and have 3 r parallel is equals to 4. Then you divide by 3 on both sides so that it cancels. Then your r parallel is equals to 3 divided by 4. What is that? It's 1 comma something. Let's see. Shreyas. Then you are having 1,33 ohms. This is now the resistance of the parallel connection is 1,33 ohms. Then you can therefore say R total is equals to 3 ohms plus 1,33 ohms, which is equals to 4,33 ohms. That is how you calculate the effective resistance or R total. I'm not sure. Do you guys notice your mistake on this one?
Yes, sir.
Mm. But wait, guys. Your silence is scaring me. I just got one response. Am I confusing you there on that one? Is it everyone who's been confused by what I was doing there?
No, sir.
Okay. 2 responses are enough. I'm just going to continue. Silence means alma lesarek. So let's now move on to the next question. So the truth is, if the question says calculate the effective resistance, they are simply asking for the total resistance. That's what is meant by the effective resistance. So now let's try to calculate the reading on A1. So when the question says calculate the reading on A1, what exactly do you guys think they want you to calculate? When they say the reading on A1 is this one. What do you guys think they want you to calculate?
Total current.
Yes. Yes. They want you to calculate the current. So remember, we have R tot, which is equals to 4,33 ohms. Let's just have it there just in case if we need it. Okay. Can someone tell me this current on A1, is it the total current or is it the splitted current?
Total current. Total current.
Yes, 100%. So that means when we use this formula of V is equals to IR, since it is the total current, that means we must use the total electricity and also the total resistance. Does it make sense, guys?
Yes, sir, it does make sense.
Okay, so what is the total V? Is it not 15 so that we can get the total current? What are we going to multiply with? Are we not going to multiply by the total resistance? So that means I is equals to, you just divide by this on both sides so that this one cancels and then 4.33. What are we having there? It's 15 divided by 4.33. We are having 3.46 amperes. I'm not sure if it's everyone who's happy with that one. Bantu Bagit,
Yes, I'm happy with it.
does it make sense to everyone?
Yes.
Yes, sir.
Yes, sir.
Yes.
Okay, 100%. So now, let me remove all of this because we have calculated. So the next question says the reading on V1. Can you guys see where V1 is? They want you to calculate the reading on V1. I'm not sure if you guys are able to notice where V1 is. And also, is there someone who wants to suggest how can we calculate the reading on V1? Mm. Okay, let me make you guys aware of something. When you have a parallel connection like that, let's say this is R1, this is R2. If they connect V there, V on R1, this thing, that same V, it's actually the same V that we're going to have on this side of R2. This is that R2, this is that R1. So this same V, if maybe R1 there, it reads 17 volts. That means if they take that voltmeter and they connect it here to read the V on R2, for the fact that it's still on the parallel connection, it is still going to read 17 volts. Again, that same V, it is still the same. Let's say there is R1, still there R2. It is still the same as this thing connected through there. Still the same V. It is still going to be 17 volts. So if, for example, they say calculate the reading on V1, that reading on V1 is the same as the reading on V2, is the same as the reading also on V of that whole parallel connection. I'm not sure. Do you guys understand what I've just explained there?
Yes.
Okay, then it's fine. So now, this is how you can calculate the reading on V1. So the reading on V1 is going to be equals to IR. We know the formula is V is equals to IR. So I can use the R of the combined. Also use the I that passes through the combined. What was the R combined, guys? Was it not 1,33? For those of you guys who remember. Do you guys still remember?
Yes, sir. It was 1,33.
Okay, so now the current passing through the combined, is it the splitted current or is it the combined current?
Combined.
Yes. Yes, 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 yes. It is the combined current because This is the combined resistance, which means what is the current passing through the combined resistance?
It is the total current of 3,
Yes. Yes. So that means you're just going to say 3,46 multiplied by 1,33. This is equals to what? What is that, guys? 3,46 times 1,33. It is equals to 4,60 volts. So that means the reading on V1, it's equals to 4,60. If they also connected the V there and say what will be the reading on V3, there is 2 on V3, it is still going to be that same thing. If they connected another V number 4 there and they say what is the V there, it is still going to be the same V. So that means on parallel connection, if you have one resistor that side, V is the same as if on one resistor this side, V is still the same. It's also V the same of all of that. But you need to be careful of something here, Kwesi. If you use the resistor or the resistance of the combined, you must use the total current. But if you use the resistor of the 4, you must only use it if you know what is the current that is flowing through this side. If you use the resistor of 2, you must know what is the current flowing through that side. Then you can say 2 times that current flowing through that side is going to give you this V. And that same V, it is the same as V connected on this side, also connected on that side. So that means on parallel connection, the V is the same for these resistors. What differs? What differs is the current because it splits, but the V does not change. I'm not sure if that makes sense, guys. I'm not sure. Does it make sense to everyone what I've just explained?
Yes, sir. Yes.
Yes.
Okay. Then in that case, let's try to have a look at the last question, which says the reading on A2. Is there someone who can explain what do you notice about that parallel connection regarding that A2? Is there someone who can just say something that comes to their mind when looking at that electric circuit where they say the reading on ammeter 2? What can you say about that, honorable member? Remember, guys, in case if you've got no idea, you can just let me know so that I explain.
We're supposed to be calculating for the current in the parallel parallel circuit part, which is A2.
Which is 18. You said 18.
A2.
Oh, A2. So what Hamisa is saying there, in short, she's simply saying she knows very well that the current is total from the cell, and then it goes like that, and then when it gets to that point, it splits. Then the other current will flow through that other side, other current flow through this other side, and then that point there it joins, and then it continues, and then it circulates. So can someone explain in terms of what happens regarding the split of current? How is it going to split according to you when you look at that?
More current would flow by the 2 resistance path than the 4 resistance path.
More current will flow through the 2 ohm resistor and less current will flow through the 4 ohms resistor. So let's now try to calculate the reading on ammeter 2. That same formula, very, very much important, guys. You just need to know in terms of what to substitute. Okay, so what is V parallel? Did we not just calculate it? What was it? What was that value, guys? See, now I forgot.
4,60.
Yes, 4,60 volts. Yes. So can you see? If you're going to substitute the V parallel, that means whatever here, you must also calculate for the V parallel. What is that V parallel there? Is it not 4,60? So what are we calculating exactly? Are we calculating current? Yes. So we're calculating current there. So this is the current through the 2 ohm resistor. That is why there we are going to substitute that 2 ohm resistor. So that means you can just divide by 2, divide by 2. That cancels, and then you know your current is equals to, I think it goes 2 times into 4. I think it goes 3 times into 6. Then it's 2,30 amperes. So that means the current flowing through this side is actually 2,30 amperes. I'm not sure. Does it make sense to everyone?
Yes.
Yes.
Yes, sir.
Okay. So if 2,30 amperes is flowing through this side, how much of current will be flowing through this side then? That's my question. We are done with the questions for the day. So now I'm just asking my additional questions. How much of current will be flowing through this side, or how can we calculate it? Mbalenhle, how can we calculate that? Marabantu bakithi.
Can I
Bantu
please
bakithi.
answer?
Yes. Go for it.
It's total current minus the current we just found.
Yes. Okay. We just said a
V equals to IR 4,
wait, who's speaking? Okay, we just said the total that is flowing through in there. We calculated it. This is the total current. We said it's 3,46 amperes. So now we just calculated the current flowing through that side, guys. We said how much was that? Is 2,30 amperes. So we just want to know how much of current will be flowing through this side, guys. If this is the total water going through in there and the other water goes through that side, that means the other water will come through this side. How much is that? Will it not be total minus that? Then it gives us there. So it's more like it's 3,46 amperes minus 2,30. What is that? Is it 1,16?
1.16.
Yes. So that means 1,16 amperes will be flowing through this side. And it's true. Can you see? More a current will be flowing through that side because of less resistance, and less current will flow through this side because of more resistance. I heard honorable member was speaking there. You can still use that same formula which says V is equals to IR. V is still the same. What is V? We calculated it to be what? 4.60. It's equals to. We want the current flowing through this side. So what is the resistor on this side? Is it not 4? Then this divided by that, what is that? Let's see. 4.60 divided by 4. Can you see? 1.15 amperes, which is a value closer to a 1.16. You cannot get that because of the roundings, because of the effects of the roundings. So whichever way that you do, you are still going to get a mark. I'm not sure if you guys understand that part. Does it make sense to everyone, guys?
Yes.
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
here comes a question. What will be the reading on the 3 ohm resistor?
Reading of current or volt?
Let's say I connect a voltmeter there. That's a very good question. That's a very good question because here we can measure the current or the voltage. So what will be the reading on the voltage connected across the 3 ohms resistor? Baleka ngenyawo zobili, ezinye izinto azivuni ingqondo, azivutha. Baleka ngenyawo zobili, ezinye izinto azifuni ukuthi ucabange kakhulu, azifuni ludo. Bale. Bantu bakithi, are you still thinking there?
The answer is 10.38 volt.
Hey, uyenze kanjani ntombo? Uyenzeni lapho?
I use the method V is equal to IR.
Okay, she used the formula V is equals to IR. Okay, V is equals to IR. What did you substitute?
I substitute current and I put 3.46. Then for resistance I put 3.
Yes. Let's see. 3 times 3.46. She's getting 10.38 volts. Yes, this should be an answer because the current passing through there is that total current, and there it's R. That's how you calculate the V or the reading on V. Otherwise, so you can say, you know that V total is equals to the V on that 3 ohm resistor plus the V on the parallel connection. You know the total electricity that you want to buy is 15 volts. You want to know the V that is going to the dining room. What is the V that went to the sitting room? Was it not a 4.60 volts? So that means this minus that. What are you going to get over there? Let's see. 15
10.4.
minus 4.6. Yes. So that means the V that goes to the kitchen is equals to 10,4 volts. Can you see closer to that? Because of the issue of roundings, that's why you might not get an exact value. But whether you do it this way or that way, I'm still going to give you a mark over there. I'm not sure. Did you guys understand the business of the day?
Yes, sir.
Mm.
Yes, sir.
Muzozozo, are you happy there?
Kuyazameka sir.
Okay, 100%. So guys, thanks very much for joining. I hope you guys did enjoy as much as I did. So I think tomorrow I might need to bring some more questions similar to this. So I'm just going to get a question from one of the previous exam question papers. Same time, same place. We'll try and give it a try. We'll just have to do this chapter until everyone is confident, and then from there we'll move on to something else. But otherwise, thanks very much for joining. My name is Desmond, and I'm out.